All right, everyone. I am here with Mark Riedl. Mark is a professor at Georgia Institute of Technology. Mark, welcome to the TWiML AI podcast.
Hey, delightful to be here. Thank you.
Hey, I'm really looking forward to our chat. We've been Twitter friends, Twitter connectees for quite a while, but it's been, I think, a long time in the works trying to get this conversation going. So thanks once again and welcome. We usually start these conversations by having you introduce yourself to our audience. Tell us a little bit about your journey and how you came to work in AI.
Yeah, well, when I was a kid, I watched this movie called Tron, and I've been trying to get it to the gaming grid ever since.
The one redeeming quality of Tron.
But well, maybe that went back too far, right?
How'd you feel about the reboot?
It was okay. They changed the light cycles. Can't be too happy about that. But you know what? Ever since then, it's kind of been a series of happy accidents. But my voyage into artificial intelligence and machine learning came through human-computer interaction. So I got really interested in this in school, took way too many psychology and human factors classes. And that was even before discovering this thing called artificial intelligence. And the day I took that class, I was hooked. And then somewhere along the way, I got invited to explore some research, got invited to look at AI for computer games. And from that point on, like everything just kind of came together.
Nice. When you started with this focus on AI and computer games, what were some of the things that you were looking at?
Well, we were looking at, and this was, gosh, I don't want to say how many years ago this was, but we were looking at adaptive games. So we wanted to know whether games could change based on what the user wanted to do or what the interests of the user were. And this is sometimes called interactive storytelling, the idea that you don't have to follow a linear course through a computer game with all these plot points. You could decide to do something different. Like maybe you could even decide to be the bad guy, right? Mm-hmm. And then the story would have to change or twist or add new elements into that. From there, it became quest generation, then it became story generation. Then we kind of eventually put the graphics aside and just said, well, can we just write a novel? Can we write a story that people would actually want to read? And been working on that ever since.
Nice. And so when you think about your kind of broad research, focus areas under this banner of storytelling, like how do you articulate all the various things you're working on and how they tie together?
Well, the simplest tie is that I get to work on artificial intelligence and have fun because it's stories and games. But but seriously, I think broadly my umbrella of artificial intelligence is something called human-centered artificial intelligence, and this is turned out to mean a lot of different things. But for me, it's about centering the human inside the algorithm, or with algorithms around the human. Really, instead of pushing the human off to the side. For me, that means, can we build AI systems that enrich the human experience? Entertainment is one way of enriching the human experience. Storytelling is another way. We can do it through design, so building explanation systems that help people do their jobs better. But also, you can kind of flip the equation around and say, well, if you want to enrich the human condition, do we have to build AI systems that actually understand the human condition? Because maybe AI systems and humans are a little bit alien to each other. They think in very different ways. The algorithms in the computer are not the same as the mental processes that go on inside the human mind. So how do we reconcile that bridge? Or how do we build a bridge between these two sorts of alien intelligences? And then how do we use it to do interesting, fun, or even fundamental things?
Mm-hmm. And so in the context of storytelling, where do those two threads connect?
I look at storytelling as actually this thing that brings a lot of different AI problems together. So if you think about humans, let's start with humans, right? Storytelling is this fundamental part of the human experience, the human life, right? We do use it for entertainment, but we also use it for education. We use it for training. We use it to build rapport, human to human. We
Yeah.
kind of chat around the dining room table. What was your day like? These sorts of things. So this is this way of humans connecting to other humans in a very rich modality of communication. And so, but this is something that computers don't engage in. They don't understand our stories. They don't understand why we tell stories, and they can't communicate back through stories, even when that's the most appropriate use of communication. And just to kind of like give you an example of why this is how this is such a powerful modality, like one of my favorite stories in the world is only 6 words long. It's attributed to Hemingway. It's you might have heard of it. It's baby shoes for sale, never worn.
Yeah.
Right. Those 6 words can convey just a massive amount of emotion. There's a story behind it. Why are these shoes for sale? Why were they never worn? Should I be sad? Is there something else going on here? Right. But in just conveying that, I can convey these rich mental processes inside the listener. And, computers are not communicating like that. And the flip side is, if we said that back to the computer, they're not going to understand all the nuance that went into those 6 words.
Right. Right. So how do you begin to get a computer to think about what the listener is thinking about?
That is that's the central challenge, right? So because this is human to human communication, you do want to think about what the listener is thinking about. Right now we do a lot with in artificial intelligence and machine learning with big data sets.
Mm-hmm.
This has been a godsend, right? I mean, we see amazing things. We see GPT-2 and GPT-3, these text generators that just kind of spit out such human-like language. But they're also not very good at planning out what they're saying. They're kind of these, they're sometimes referred to as intelligent babblers or smart-sounding babblers. Like they kind of say, here statistically, if I have this set of words, I should say this next word, then I should say this next word, and I should say this next word. That's very good for creating text that looks kind of plausible.
Right.
But stories are not just about babbling, right? Stories have a goal. Stories have a point. So when here I am talking to you, Sam, and you ask me a question, I have to figure out, here's my goal, here's the point I want to drive to. Now, how do I lay out those words and thoughts to get to my goal? So I've got to plan these things out. So the first part of it is, how do you do planning in language? Instead of looking backwards to what I've said in the past and whether my next word is statistically plausible, I have to be looking to the future and saying, based on where I want to go, does this next word or next sentence support my goal? And then the next part, and that's hard enough, by the way, but the next part is, kind of a theory of mind, which is, am I choosing words or statements or phrases that will have the cognitive effect on the hearer, on the listener, or on the reader that I want it to? So going back to the baby shoes for sale example, if you're not a parent, maybe that is not a particularly powerful story. If you are a parent, it is powerful. So what are the cognitive thoughts that are evoked by these particular words? And are they the sorts of thoughts that we want people to have?
When you talked about the planning part of that, there is lots of work around planning in a traditional sense and the application of machine learning to logistical planning and planning in a shop floor for robotics and that kind of thing. Is your work able to draw any inspiration or even techniques from other domains and applications of planning, or is planning in the storytelling sense its own unique animal that requires ground up thinking?
Oh, no. The reason I love working on storytelling, again, is I get to work on fundamental hard problems that are broader than just storytelling itself. So So when I talk about planning out a story, like we draw a lot from historical planning, literature, logistics, reinforcement learning, all these sorts of things. So what we're really trying to do is we're pulling threads together. We're saying, all right, planning plus language. How does language change the planning process? and so on and so forth. What happens when we put common sense reasoning inside the planning process? Maybe UPS doesn't need common sense reasoning inside their planning process. Maybe they do. But we're drawing another thread together, and we're saying we're going to connect a bunch of other things together that other people have not had to put together because maybe they weren't kind of looking at this holistic, humanistic sort of problem. Mm-hmm. So when I started working on story generation, we did a lot of symbolic planning systems.
Okay.
And actually, we were able to generate some pretty good stories, because making a story is not that different from, setting up the logistics for a package or a store, right? Uh-huh. Just we're talking about fairy tale characters instead of packages and whatnot. And then at some point you run into a limit and say, all right, well, we're using a lot of hard-coded data or models. Now we want to look at more learned models. Can we now start to learn from reading stories as opposed to typing in kind of logistical symbols and so on and so forth? Mm-hmm. So, like anything, as we solve a problem in the way we think is the right way to do it first, then we say, are we there yet? And if we're not there yet, what do we layer on top? So we layer on top data, then we layer on top theory of mind, then we layer on top common sense reasoning, and so on and so forth. And we just build in that way.
Mm-hmm. In the case of theory of mind, what can you give us an example of how you've layered that in?
Yeah, so some of the work that we're doing now, and I should give a lot of props to one of my former PhD students, Laura Martin, who just graduated, as well as some of my other team. We went in and we looked at these neural language models that we see in the news all the time, and we said, mm-hmm. Why aren't they able to? Why do they make weird choices in terms of coherence? Why do they go off the rails and kind of go into weird places? And we kind of looked at it and say, well, because they're not really thinking about whether what they say is building up a coherent, any connections to the past, mm-hmm. right? So we then said, well, let's get a neural system to generate. All right, so now we're dealing with neural networks. But then we said, well, you know what? Let's actually go back to the past. Like in the past, we had symbols, and symbols had meaning. And we think symbols have meaning to humans. So let's build in parallel a symbolic layer as well as a neural layer and have the two reference each other. So here's a fact. I say something, my neural network says something. Let's convey that as a fact. Is this fact consistent with previous facts? Does this fact build on previous facts? And so now what we're kind of doing is we're kind of assuming if these are the sorts of facts that people will recognize in the language itself, then maybe this set of symbolic facts is actually a reader model. It is what we think the human is thinking about or inferring from the language, kind of a high-level semantic kind of orientation towards the language. And if we can get that high-level semantic model correct, then our stories that we generate should come out more coherent, because we can pick and choose. We can say, if I say this connects to my symbolic layer. If I say this other thing, it doesn't connect to my symbolic layer, so it's probably off topic. And mm-hmm. we were able to show that we can, in fact, improve the coherence of stories. We can keep the stories on track longer, and people report that they see more coherent as a whole.
Nice. And this is using off-the-shelf language models, like some of the ones you mentioned, GPT-2, GPT-3, that kind of thing?
Yeah, we do a lot with we might do some fine-tuning on them, whatever. But by and large, we're taking these very large models, much larger than the ones that we can train or are interested in training. And mm-hmm. we're basically putting a control layer on top. We're saying you're not allowed to say something unless it connects to my theory of how humans understand the language. So if you babble and it doesn't connect to my theory, my control theory, then I reject you and I ask you to come up with something else.
And your control plane, control theory, that sounds like it's not a learned layer or mechanism. Is it, or is it, exclusively rules based? Like, how do you create that symbolic layer?
Yeah, it's a combination of multiple things. We've looked at multiple ways of doing this. we find that there's a lot of heuristics or rules that we can apply there, which kind of dips back into the old classical planning sorts of literatures, cognitive science, so on and so forth. Sometimes we also turn to learned models. We might say, well, what can we teach an AI system, a second AI system, to predict what humans will think? And so teaching AI systems to understand common sense. So we'll kind of, and now what we're starting to do is we're starting to experiment with a combination of both kind of rule-based cognitive models plus learned models together. Because I don't think any one system is quite the right way of doing it.
Mm-hmm. And so in describing the symbolic layer, at least the example that you gave early on was essentially focused on maintaining consistency and coherence within the story. That is a part of making a story, plausible or impactful for a human. But there's also, word choice and other aspects of, what the reader listener is thinking of. And it brought to mind for me, a task that's almost like, invert sentiment analysis, like sentiment conveyance or something like that. Is there an element in your work that is focused on kind of the emotional impact of word choice by these systems?
Not at the moment, but our long-term goal, yes. And so I'll kind of spill my beans a little bit and talk about kind of where some of this work is going.
Mm-hmm.
What I really want to do, and what I think would be a really kind of amazing demonstration of these technologies, is to do build a system that can generate suspenseful stories.
Yeah.
And suspense is emotion, but suspense is a particularly interesting emotion where you seed an idea. So think of James Bond, right? So James Bond looks like he's in trouble. He's going to get captured and tortured and killed by the bad guys, right?
Mm-hmm.
But then he always escapes at the end, right?
Mm-hmm.
So the way to convey suspense is to seed an idea in the mind of the watcher or the listener of a negative consequence, and then at the last minute you pull the rug out and you reveal that there's a way out, right?
Yeah.
So suspense, I think, is very powerful emotion, very hard to create accidentally. We can do surprise. Surprise is easy to do accidentally, but suspense requires buildup. So you have to seed all these points in the story because you're planning ahead. So you have emotion, you have planning, you have expectation. So what do humans think are going to happen, as opposed to what is actually happening?
Mm-hmm.
And so this to me, this notion of suspense brings again in all these threads of all these really kind of fundamental problems of modeling, planning, so on and so forth, in kind of a fun little demonstration.
Mm. Yeah, it made me think about from there are all these story archetypes like the hero's journey and what have you that in theory, could serve as like a rule base or some set of heuristics for a generative algorithm. Is that kind of what you have in mind with this, with suspense being one of those, or are there other ways that those kind of story models come into play in your work?
Yeah, so I think humans have a lot of expectations. So I talk about this idea of expectations, right? So
Yeah.
in some ways, storytelling is self-referential.
Mm.
We watch a lot of movies. We build this schema of what movies should be like, and then you play with that schema in interesting ways. This is getting like into narrative theory here, and away from the AI, right? But but that's also important, right? So you don't want to tell stories that don't fit people's expectations. You also have to deviate from those expectations. Just modeling what is a human's expectation. Well, that's we believe that we can get that from data. So read a lot of stories, read a lot of movie scripts, those sorts of things. You get a sense for what stories tend to do.
Mm-hmm.
But data again is backwards looking, right? I'm not trying to emulate every story I've seen before. I'm not trying to recreate the stories of the past. I need stories of the future. So we start from that. We try to learn a model of expectation of what should or should not be in stories. from the data. But then the planning is the look ahead part to say, well, what is the author's goal? Do they want the hero to win? Do they want the bad guy to win? Do they want to create suspense? Do they want to create sadness? Based on those two things coming together and the push and pull of those two things, that I think, at least that's my kind of idea of how stories can be told.
Mm-hmm. It strikes me that to some degree, if you figure this out, it would be very valuable to these film studios who want to know if a story is going to resonate with an audience early. Is that something that you're focused more on the generative side, but is that something that is that a solved problem because we can kind of do predictive things? We're, I think, a bit further along with predictive things with machine learning than generative. Or do you think there are interesting things happening there as well? Is it even something that you're paying attention to?
Yeah, I pay attention to how AI is being used in various industries. I'm not 100% convinced that predictive modeling in, let's say, Hollywood studios to find the next best, blockbuster hit is that big of is going to have that big of an impact. I mean, I think someone will find a way of making $1 billion off of this, regardless. Right. But again, it's backwards looking.
But it won't
right?
necessarily lead to better films. Is that the core contention there?
Yeah, I mean, if you're looking for things that look like the past, then predictive models are very good. Because in some sense, all machine learning is pattern matching. So I find patterns I've seen before, I activate on that.
Yeah.
We're going to need something else to say, well, here's something that's completely new, that's never been seen before, but could be a big hit. But I think that's a big ask for an algorithm. I mean, algorithms right now, I'll be fully honest, we're talking about baby shoes for sale and very complicated sorts of stories, suspense. We're lucky to put a couple paragraphs together, really, and have it make sense all the way through without someone saying, wow, that was a weird direction that this thing just went.
No, that's good context to ground on. You talked about how story is self-referential and the role of human expectations, and it seems like there's a kind of a fine line there where for the story to be interesting, you want it to have just enough surprise, but not so much that it's kind of, like you said, off the rails, or maybe avant-garde if it was produced by by an artist. How do you kind of control for that in the systems you're building?
I don't want to say I have all the answers yet, but what we're I also, while I look at storytelling, I also look a lot at human creativity and AI creativity. And I think, creativity is kind of this weird thing. I think we all have an intuitive sense that some things are creative or not. But I like to think about intentional creativity. So one of the big issues that machine learning algorithms have right now, when they're used to create, whether it's stories or text or dialogue or poems or pictures even, is unintentional creativity versus intentional creativity. So unintentional creativity is randomness, right? So sometimes AI systems, they just make a statistically improbable decision because they're statistical machines, and it ends up being a happy accident, and there's something kind of beautiful and unexpected that comes out of the computer, but it's completely non-replicable. Right? You do it again and you get something boring because a different random choice was made. So humans seem to have this ability to say, and I think it's because we're goal driven, whereas AI systems aren't always, and machine learning systems aren't always goal driven, to say, well, I need this thing to be different than the things I've seen in the past. Now I have to, in some sense, search through all the different ways to make things different. How do I know which differences are good differences, which differences are bad differences, which differences are just random, unintentional noise that sometimes comes out good and sometimes comes out bad? So I don't think we have a good theory of intentional creativity yet.
specifically to AI, or broadly in the sense of the human element of creativity?
Well, I think for both. I'm not I don't study psychology, of course, but I think definitely for AI systems, um, we don't know how to build systems that can make kind of distinguish between good and bad, um, as well as they should.
Mm-hmm.
Right? I think we're very good at building practical systems. If I have a practical objective function, I want to maximize X or I want to minimize Y. I think we've gotten very good at that. But the problem is maximize enjoyment. Like that's probably the goal for any creative system, or maximize pleasure or aesthetics. How do I define that mathematically? How do I define aesthetic or good or pleasurable in art, story, visual arts, anything like that? I don't think we know. And what we do is we turn to our toolbox and we say, well, what I can do is I can at least compare it to the past. So train on a whole bunch of images. I'll get more images like that. If I train on pretty images, I'll get pretty images. But who's creative there? The person who put together the data set, not necessarily the algorithm. How do we get an algorithm to say, all right, you gave me a whole bunch of pretty pictures, but I think I could change this in a particular way and go off on this weird tangent over here and get something better.
Mm-hmm.
That's what we don't know how to do. And humans seem to be able to do it. And I don't know if it's just because humans have a lived experience that is much broader and greater than any AI system, or whether there's some mechanisms in the human mind that we don't know how to model yet. I think that's an outstanding issue.
Mm-hmm. Are there adjacent areas in machine learning that you're most excited about for their potential contribution to the kind of research you're doing? Like, maybe a few years ago you might have said transformers if you foresaw all that was going to bring. What's the thing that's next? Is it some crazy reinforcement learning thing, or do you not know yet?
Well, I'm very interested in like I think story generation is going to result in new sorts of models and new sorts of algorithms. But but aside from like the big grand AI challenges of can we build systems that generate stories from scratch, I'm also very interested in the applied side of storytelling. And to that end, one of the things I've been working on is explainable AI systems. So explainable AI systems is this idea that we have these machine learning systems. They're black boxes. We don't understand what's going on inside of them. They make decisions which might be wrong or correct, but confusing. And so there's been a lot of interest in kind of quote unquote opening the black box.
Yeah.
I've been thinking a lot about end users. So the people who are going to use the Roombas of the future, who are going to have the Roombas go off and do really weird things, and they're going to ask why. Why did you do that? Why did you run over the cat, or why did you wake up the baby, or things like that? And the sorts of things that we're doing now in interpretable AI of I'm going to do data analysis on this neural net and figure out which neurons are misfiring. That's not the sort of thing that end users of Roombas are going to want to know, right? And my theory is that the explanations that are going to be most useful to non-technical people are going to be the ones that are going to feel like stories. So if the Roomba is saying, well, I went over here because et cetera, et cetera, et cetera, in some sense, they might be telling a little story. That story might be tapping into a theory of mind that says, all right, well, how can I help my human user reconcile their understanding of what the right action was and my understanding of what the right action was? I'm not sure who's right or who's wrong here. We just have a different understanding of what was right. And can I explain through sharing experiential stories why I did the things I did, I being the robot here.
Right. And how far along are you in that direction, that research area?
We have a few basic systems, nothing particularly complicated, nothing I would even say is really telling a story. At this particular point, we got into this work in end user explanation, and then we realized we actually didn't know what a good explanation was for end users. So my students and I have been running human factor studies to say, well, what is it that humans actually want from an explanation? Okay, I think I understand the debuggers at
Explanations
Google.
in general or specific to explanations of neural systems, for example?
Of general, right? So
Mhm.
like whatever's in that black box, what is it? What is the explanation doing? Is it is it helping them understand? Is it helping them debug? Is it helping them just feel good about owning a strange, mysterious thinking device in
Mhm.
their house? What kinds of explanations make them trust the device and want to use it more versus less? What makes it a more pleasurable ownership experience? Right. So it turned out there's a whole set of human, and this goes back to my interest in human computer interaction, actually.
Yeah.
There's this whole set of questions about what humans think about when they use complicated, intelligent black box devices. And we didn't have the answers to any of these things. So we actually kind of set the algorithms aside and said, well, before we build algorithms, we actually need to know what the algorithms are going to target.
I would imagine that there's not a single answer to that. That some people want to know a lot more about what's happening in order to help them, for an explanation to be satisfying to them, whereas others, just get me to the point.
Yeah, absolutely. We're finding it's vastly multidimensional. We just conducted a study looking at people with computer science backgrounds versus people without computer science backgrounds and doing
Mhm.
explanations. And as you might predict, you know, people with technical backgrounds have a very different orientation towards their devices, towards their automated systems in their homes. Like to them, they want to figure out what went wrong and how to make that never happen again.
Mhm.
People who have aren't engineers, you know, they had a very different orientation. They just wanted to feel that something was thinking inside, right? And just
Mm.
talking through the process of what the AI system was doing was just enough, and it made them happier, right?
Yeah, yeah.
And that was, maybe in retrospect obvious, but also kind of like a really interesting result.
And so, granted that you started with this goal of trying to build explanations for these black box systems, you took a step back to try to understand what a good explanation is. When are you done there? That sounds like a huge challenge, but how far do you need to get there before you are able to return back to this core challenge, or are you kind of pushing on the different directions in parallel, and how do you keep them synced up?
Yeah, I think you can do some of these in parallel. I think we know enough for now to start revisiting the design of algorithms. And so, like to me, human-centered artificial intelligence is you have to understand what it is about the human experience working with an AI system before you know what to build.
Mm-hmm.
So asking those sorts of questions about the human experience is the first step to any good research. Right. So I felt like it was important to step back. Now I think we know enough to say, well, we can start targeting different applications and different use cases with algorithm again. Because now I know what I think the algorithms need to do. And it
Mm-hmm.
wasn't necessarily what I thought they needed to do, 2 years ago when I first started thinking about this.
Can you drill in on that point? Like what do you think now versus what you thought then?
Well, we thought that explanations were going to need to be a lot more technical than they were.
Mm-hmm.
And what we've really discovered is that a lot of explanations, for certain types of users in certain types of circumstances, and I don't know how universal this could be, but at least
Mm-hmm.
right now it seems that a lot of the explanation systems are going to be about confidence building. Okay, so there's this black box. I don't know how it thinks. I don't know what it's thinking. Does it think like me? Does it think like something else? Does it even understand what it's doing? Or right. And so communicating in a way that sounds somewhat humanistic or human, um, an AI, a system that says, here's what I know about the situation that I'm in. Here's what I'm seeing. Here's what I think should be done with that sort of situation. May be the sort of explanations. which is very different from this is why my algorithm made choice A versus B.
Right. It also makes me think a little bit about the role of story and the relationship between, two things over time, like the system and the human. Maybe the goal of the system is to, gradually, increase the human's confidence or understanding or some other metric over time. And is that something that we, how do we get to that?
Well, I think I mentioned one of the reasons why storytelling is useful from human to human is rapport building.
Mm-hmm.
Right? Like before the pandemic, we used to go to conferences, and there's the where are you from? How did you get here?
Right.
What are you working on? These chit chat sorts of things. Often lightweight stories. We're not telling Steven Spielberg style epic thrillers, right? We're just kind of saying, here's my daily life. Here's who I am, kind of conveyed in this interesting kind of story-like way.
Mm-hmm.
Can AI systems put people at ease? Make people want to use them more? Have confidence in using them by doing this chit chat and unfolding in stories, but also listening to stories. Oh yeah, okay. This is the story you're telling about you. Now I have an understanding of how I need to respond to you and act with you. That I think would be kind of an amazing sort of step forward. Also one that has a little bit of risk, right? We don't want to artificially create trust when we shouldn't artificially create trust. So there's a little bit of a kind of a double-sided kind of sword aspect to this as well. So we want to convey confidence or instill confidence in users and convey trust and build rapport when that's an appropriate thing to do. But we need to be very careful that we don't step into manipulation and persuasion.
And so what are kind of the future directions in the explainability dimension in that line of research?
Yeah, well, I think there's still a lot of papers to be written about the human-centered aspect of non-technical end-user explanations. And then there's, I think, going to be a lot of work to actually build the algorithms, because the algorithms that we might need to build might not be exactly the ones that we know how to build right now.
Do you envision them starting from kind of existing explainability algorithms, like adding a story generation layer to Lime or something like that, or are they kind of ground up more likely?
It's a little bit unclear, I guess. It's hard to predict the future, but what I do think is, I think our explanation systems are going to have to borrow a lot from the sorts of questions I've already been looking at in the storytelling domain. So a theory of mind. So how do I answer this question about what I just did? Well, what is it that the user actually wants to understand here? What do they already understand about my behavior? I'm going to have to tune to that, tune to my reader, tune to my listener, tune to my audience, sort of thing. Planning out the explanation, right? So if it's going to be more than a single utterance, now I have a goal of helping you understand what I just did. Well, maybe I'm going to have to say 3 or 4 or 5 different things to get you to understand that. So planning ahead, as opposed to just kind of using statistical language models, is another thing that I think is very likely to play an important role in here. So whether we build from there into something new, or we take what's already out there in existing explanation systems, we layer on top, I'm not sure. I think it could go either way.
Nice. Yeah. I wonder if you can maybe take us through some additional examples of papers that you and your team have written around storytelling in general, not necessarily the explainability, but that too, just to give us some more concrete ideas of how you start to kind of lay the bricks or put the pieces in place to push this broad research agenda forward?
Yeah. So I like to build big systems. So a lot of my papers are like, here's a piece of the system, here's a piece of the system, here's a piece of the system.
Mm-hmm.
So in 2017, 2018, I can't remember, we had a paper at AAAI, which was on using neural language models to build stories. So that was really kind of an early example of how to use neural generators to build stories. But it was doing a lot of the things I just talked about as, kind of a naive way of doing it, right? We just statistically sample. We kind of run the sampler forward until we get bored of the outputs. Doing that work was when we realized we had to be much more forward-looking, goal forward-looking, as opposed to statistical backwards-looking. So in IDGCAI, I'm forgetting the dates on these. Might have been 2018, 19. So about a year and a half later, we had an IDGCAI paper that looked at goal-driven storytelling. So given a goal, I want happily ever after. I want the hero and the heroine to get married. How do we force a neural network to drive in a particular direction? And that was very successful. And then the next piece of work after that, which is very recent, was Laura Martin's Thesis, which should kind of come out any day now, literally. Was really now this neurosymbolic. Gotta talk about her work. It's great. Was the neurosymbolic thing to say, well, statistically, even if you drive towards a goal, you can still make these weird statistical leaps that people just don't understand. So now we wanted to tie the neural generator to this symbolic model of what we thought how humans would link the different parts of the story together to drive the story generator forward. So that was then the reader model or the listener model being incorporated on top of that. And that kind of brings us to where we are now. We've done a little bit with common sense reasoning. We had a AAAI paper just this year about trying to incorporate common sense. So each paper kind of adds another little dimension to the story of storytelling, I guess.
Nice. And how did you approach the common sense problem?
Well, common sense was just one of these things that I felt was just missing from the beginning of storytelling. All right, it's really what is, if you make common sense mistakes, people observe them immediately. Okay, so you make a mistake about telling something as simple as going to a restaurant. You get things out of order, and people are like, "Whoa, like, what the heck is your ass?" Storytelling is great like that. You can't get anything past the readers. Like, the readers will call bullshit on you very fast, right? So we wanted work to be looking at how we could use models of common sense reasoning to factor into our AI systems.
And so did you use kind of existing off-the-shelf, quote unquote, existing research in common sense reasoning, or did you tailor something to the specific problem?
We did. There's this great piece of work out of University of Washington. Not our team. It's Yejin Choi, Antoine Bozelet, and the great crew over there. They put together some common sense modeling neural networks that can predict, what people will think about a sentence. So we were able to bootstrap off of that to save ourselves the trouble of building big data sets and training off of those things. What we brought in, though, was the notion of how it folds into the story planning process.
So not kind of naive filtering of things that don't pass the common sense test, but incorporating that signal into the planning process itself.
Yeah, we've done it both ways now. We can filter. So this sentence doesn't pass the common sense sniff test. So we're going to filter and we're going to regenerate until we pass the sniff test. We can also use common sense to actually plan forward a little bit. We can say, well, if I see this, this idea of expectation comes back again, right? If I see this, then my common sense model says I would expect that. So I better put that into the story.
Are there kind of top line takeaways or lessons from your work on story that you think should be more broadly applied by researchers or practitioners in other areas of AI?
Well, I think, again, I'll kind of harp on this, right? But the idea that working on storytelling allows us to address these fundamental problems. So, I do think that some of the algorithms we're putting together for storytelling can be pulled out of the storytelling framework and be used for, let's say, human AI or AI interaction, trying to use language to plan. So think about getting together with your friends and trying to put a plan together for the afternoon, right? What are you doing? You're planning, but you're communicating back and forth with language. So we think that this will apply to dialogue. We think would apply to, Siri style personal assistants, or Cortana or Alexa style personal assistants. We haven't tested these application areas. I'll probably leave that to other people. At the end of the day, to me, this storytelling is what makes these hard problems fun. So I kind of like to leave it in the the sphere of having fun and let other people kind of look for the applications.
Yeah.
But there's another valuable aspect of working on storytelling, which is building big systems that are not one-off papers that say, well, I have to bring together lots of things and build complex theories of how all these different models fit together. Common sense models and planning models, they don't naturally fit together. So there's a lot to learn in terms of integrating multiple types of AI styles, problems together into one thing that and see it work. And when it works, it's great.
Awesome. Well, Mark, thanks so much for sharing a bit about what you're doing with storytelling. Very cool stuff.
It's been an absolute pleasure. I'm finally glad to have had the chance to talk to you.
Same here. Thanks, Mark.
All right. Take care.